Hello, my name is John Wengert, and this is the Introduction to Scripting session recorded before the rug for the 2019 ROES Users Group. So what we're going to do is just go over a little bit of the basics of scripting, how it works, where they're used, and that should help you follow along if you attend the developer session, which will go into more advanced scripting concepts. So just to begin with, there's a couple of things that will be useful to follow along with in this presentation. One is the scripting guide, which goes through essentially the same material and more. Has all the documentation on the calls and the parameters, the data that's available, etc. And then there is also a server script stubs jar, and essentially what that is a library that has all of the classes that are defined and available to scripts just in a stubbed form. It allows you to create a jar, make calls to these classes and utilize them, and be able to compile that into your own jar apart from the server. And then when you actually execute it, you'll execute your jar within the context of the server. So what are scripts? So essentially a script is a piece of code that can be executed by the server. They can be used to add new behavior or extend the current behavior of the server. They can interact with the server environment, and they can also interact with the outside world. So there's a lot of flexibility that comes from scripts. So scripting languages. So the scripts can be written in any JSR 223, which is a specification for a scripting engine in Java that you have installed on the Java on your machine. Now, there is a lot of possible choices, and but the server installs Bean Shell. So Bean Shell is always available when you're scripting in the server. The Bean Shell is a Java interpreter, and since that is a Java interpreter embedded inside of a Java application, it gives us a lot of power to do object-level exchanges, API calls, things of that nature. So where can scripts be used? So there's three places by and large scripts are used. One of them is in reports. So when you're generating reports, you can use macros today. Well, there's a special flavor of a macro that says, hey, I'm going to embed a script inside of this report. Another area where they can be used is in a scripting agent and custom event listeners. So those are the three major areas. There's really a fourth, which is kind of linked to the report concept. Anywhere in the server where you can use macros inside of a setting, like for example, in directory paths and things of that nature, you can use the report macros inside of those. Well, since you can use report macros, you can also use a script. So arguably anywhere that you can evaluate macros, you can also use scripts. Okay, so let's start by taking a look at scripts in a report. So if we're going to use a script in a report, then we will use macros to define that we are embedding a script. And the macros that we'll use are begin script and end script. Now, the begin script macro actually takes a parameter. So let's look at its definition here. It says it takes either language period or engine period followed by a name. And the brackets around language and engine period identify that it's optional. So if you don't define a language or an engine, by default, it assumes that the name that you're providing is a language. So if we say begin script and we pass Bean Shell, then what we're saying is that we're starting a script and the script is going to be written in Bean Shell. And this is the exact same as doing begin script language.bean shell. Now, if we wanted instead to define a particular engine, we could do that. So begin script engine.bean shell space engine. So that's the engine name for Bean Shell. And you could do other engines as well. So engine.mozilla Rhino. So you might be wondering, why would I want to bother to define a specific engine? Well, maybe you have a case where you've got two different engines installed that both process the same language. Let's say, for example, you have Mozilla Rhino, which processes JavaScript, and let's say you have Nashorn, also a JavaScript engine installed. And for some reason you specifically want Mozilla Rhino. Well, the way that you can make sure that that's the case is to define engine.mozilla Rhino. And then you're saying, I'm writing JavaScript, but I want it executed specifically with this engine. And then you would then follow that with your script. And at the completion of it, you would end your script block with end script. So everything in between the begin script and the end script would be script in the language that you've defined, and will get executed. So let's begin with a hello world report. So standard computer science kind of first step. We're going to build a report that is just going to write out into the contents of the report, hello world. So let's go take a look at that. So for these reports, I've set up a rug report agent, and I am using a file called currentscript.txt as the source template for the report. And I'm going to always, when I process this, I'm going to put the output into a file in that same directory called current-script output. So that's the strategy that we're going to use to create our reports. So here is our first report. You can see current script.txt. We say begin script. We're identifying we're going to write this in Bean Shell. And then we use this G output writer, and we write out hello world, and we put a new line at the end of it. And then we end the script. And we'll cover in a moment what this output writer is, but effectively it's a way for you to write out content into the report from your script. So let's go back to the server, and we'll take any order, and we will enqueue that to another queue, which is the queue that agent is listening on. And okay, that's been processed. So now if we jump back and we look at the current script output, we can see there is our hello world. Okay, now let's take a look at the script environment that gets set up when we run a script. So when a script is run, there are three global variables that get created. The first one is G output writer, which we used in our previous example. And then there is a G report macros and G system data. So let's take a closer look at these. So the G output writer is actually a java.io.string writer, and basically anything that is written to the G output writer is going to be written into the content of the report at the completion of the script, and that's important to keep in mind. So if you're writing things out to the report and say an exception gets thrown in your script and it throws out, those things that you had previously written will not actually show up in your report because the script threw an exception out. It didn't complete normally. So that's just a little bit of a wrinkle in there to keep in mind. So when the script completes successfully, then everything that has been written to the output writer will be written into the report. The G report macros is a hash table, java.util.hash table, and it contains all of the macros that are available in the script at the point at which, or to the report, at the point at which your script is placed in the report. So, for example, your script could be in the context of, it could be inside of a unit list. And if so, then all of the unit macros will be populated in the G report macros when your script is executed each time through that through the iteration through that list. So the key for the report macros is the macro name, and then the value is the actual value for that macro. So that's how the report macros get preserved. So let's take a look at that more closely in a script. Okay, so we have changed now our current script to this script that we're looking at, which starts with the lab order ID, and then we use this little formatting macro as backslash, which basically says continue the line on beyond the next end of line, so that way we don't pick up this end of line. And then the next is our begin script. So the first thing our script does is it gets the lab order ID out of the report macros and assigns that to a variable called lab order ID. And then it writes that to the G output writer. So if we, again, jump over to our server and we enqueue somebody to trigger that script, and then we jump back and look at the output, then we can see that the output is what we would expect. Lab order ID and SAR 001504. That was the order that we enqueued to trigger the execution of this report. So that's an example of how to access macros, but you're not limited to just accessing the macros. You can create new macros as well. So let's take a look at that. Okay, so here is a script, or here is rather a report that begins with a little bit of script. It says it's bean shell, and it accesses the G report macros global variable, and this time it does a set, and I use a key of my own macro, and I set it to my own macro. And then I end the script. So the script doesn't write anything out into the report, so it is simply executed, and that's all it's done. And then the rest of this is just regular report nomenclature. So we say hello from, and then we evaluate my own macro. We got the square brackets around it. So let's run that and see what we get. Okay, and let's take a look over in the report agent, and we have a happy accident here. We actually have an error in our script, and so we get an opportunity to see what does the error reporting look like. Well, you can see here is our order ID, our batch, and the description. Admittedly, sometimes they're a little bit difficult to read. Sometimes I like to just select that line, copy it, go and do a new text file just so I can look at this whole thing separately. But this is basically telling us that G report macro set is an error. This is error at line 2. And that's because set is not the correct method on a hash table. So we don't want to save that. So let's go back and let's fix our script. Instead of set, it should have been put. And that will actually save the macro. So now, if we jump back to here and we say reprocess this, batch, that's been processed, and if we look at the output, then we get what we expect. We get a blank line, then we got hello from my own macro. So the macro, my own macro, evaluated to the string my space own space macro. And if we are wondering why did we get that initial blank line, it's because it's actually picking up that carriage return sitting there after the end of the script. If we didn't want that, then we could do something like that, which basically says, okay, skip from here forward to the next end of line. And then we would have gotten just the hello from my macro. So that is an example of how you can actually create your own macros and use those then just in your report like any other normal macro that's been defined. Okay, so we've used scripts now that write to the G output writer. We have used the G report macros to get and set macros. And now let's take a look at that third global variable that's created, G system data. G system data is also a hash table, but it contains information that really information about the environment that the script is running in. And it falls kind of broadly into 4 categories of data. The first is data about the workstation. And the second is data about the directories that the workstation is using. The third is report context, and the fourth is other. Let's take a quick look at the scripting guide and get some better idea of what those particular values are. So here we can see we've got our table of contents with the accessing G system data. So here are the 4 categories I talked about. Data about the workstation. There's a workstation name. You can get the database URL, username and password. That's the workstation's connection to its database. Its ensemble address and its ensemble port. So essentially, where is this workstation doing its listening from? Data about directories. These are all the directories that are in the directories tab that get set up, so you can find out what those are set to. Data about the report context. Now this is kind of interesting. You see report macros and output writer. So actually the two of those other 2 global variables are contained within the system data. So if you only had access to one global variable, make sure it's system data. That'll give you access to everything else. And the fourth is other handy data, and that is persistent system data, and we'll talk about that in a little bit. And then system data keys, which basically is a list of all the keys that appear in system data. And you probably won't need that, but it's there if it's needed for the particular scripting language that you're using. So let's go back to our scripts and look at a script that accesses system data. So here we have a report that contains a script, and it's in Bean Shell. And so the first thing it does is access the system data, and it gets the workstation name and assigns that to a variable workstation name. And then the next thing it does is it gets the incoming directory and creates a file object using that path. And then assigns that to the variable incoming directory. And then finally, it writes out, using the G output writer, just some information, the workstation's name, and identifying what it's seeing, the length of the directories that it's waiting upon, and how many files are still there. So let's execute this and see what we get. All right, we come back and we look at our output, and it says the workstation, dev workstation, that is the name of my workstation here, sees 106 files that are waiting to be processed. So I have a number of files that are incomplete or are directories. And so it sees those and is giving me a count. And so we've been able to access the system data to give us information in a report as well. Okay, so we've seen how to access data in the G system data, and one of the elements of data that we saw in there was something called persistent system data, and I said we'd come back and talk about that later. So let's talk about that now. So the things that are created from your script really only exist for the duration of that script. If you wanted to create an object that would exist beyond the context of the script, how would you do it? Well, that's where the persistent system data comes in. It is also a hash table, and the content of the hash table persists for as long as the workstation is running. So if you want a script to create an object that's going to continue to persist beyond the end of the execution of the script, what you would do is you would create it and then you would put it into the persistent system data. The that allows you to create these objects that can live beyond the end of a script. So one object could be basically passed off to another script using this kind of a technique. So let's go look at a script that does this. Okay, so here I have a report that is a script, and in the script I have a string. Now strings in object or strings in Java are objects, so I've created a variable called persistent string set to I want to live, and then what I do is I use the system data to get the persistent system data, and I assign that to a variable called PSD. And then I do a put of this persistent string. I use the key persistent string and then the variable persistent string. So what happens when this gets executed is that nothing is written into the report, but this persistent string has been created and added to the persistent system data. So let's run that. And if we look at the output is nothing, which is what we expected. Now let's create a second script. And what this script, or this report, which contains a script, is going to do is just like the first one, we're going to go access persistent system data from the system data global variable. And then we are going to do a get, and we pass the key persistent string, which we know is the key that we had set on the previous report that we had created, the previous script. And then we're going to assign that again to a variable called persistent string. And then we're going to write it to the output writer. And then what we're going to do is we're actually going to remove persistent string from the persistent system data. And this is just kind of a good technique, just so you don't end up adding a lot of lint to persistent system data, because it is kept around for the entire duration at which the workstation is executing. So let's go run this. And look at our output. And our output is, I want to live. So that was the string that we scrolled away in persistent system data. We ran a second report, which had a script in it, which then took it out of persistent system data, wrote it out, and then removed it from persistent system data. So that is the way that you can use persistent system data to have objects that survive, that are created by a script that survive the execution of the script. Okay, now I want to show you a slight variant on that second script where we got the value of the persistent string. So here in this script, we're getting the persistent string directly from system data. Well, how can that be? Because we stored it in persistent system data. Well, it's an implementation detail and one to be aware of, that when a script is executed and the system data is populated, it gets a copy of all the keys that are sitting in persistent system data. So you want to make sure that you don't put something into system data, or persistent system data rather, that is also going to exist in system data, like one of our predefined keys, like ensemble address or something like that. So just a little nugget of information on that. So with that, let's talk about our last point with the persistent system data, and that is avoiding naming conflicts. So like I was saying, don't use key names that the system data uses when populating G system data. I'd recommend using a standard prefix to your own keys. That way there's no danger of you using a key that we end up using in the code or we add to system data. So for example, something like, mylab_xxx, whatever the key name is going to be. With this strategy, one other caveat, I would avoid using SW_, because if we put something in there, that's typically the prefix. I'll use SW_, possibly SA or SAR, but Since I have now put it in writing, we'll use SW if we stick something into persistent system data that we're just kind of keeping transient. So that'll help avoid any naming conflicts with persistent system data. So that covers scripts and reports. Let's look now at a scripting agent. And a scripting agent is a workflow agent. So as a workflow agent, it draws work in batches from a queue, does its processing on it, and then forwards it on to the next queue for continual work in the workflow. The difference here is that a scripting agent actually has access to the batch of work that's being processed, unlike with a report. The scripting agent does have access to the batch. So how does it get that batch? Well, there's some additional pieces of information that are in the greport macros table, those being the job batch, which is an array list of RS jobs, which is a class that's provided and defined by the server. It is discussed in the scripting guide. So if you have more questions on that, you can find that there. There's order XML data, which is a representation of the root element of the order XML for the order. And then there is the name of the agent that is currently being executed. So let's take a look at a script and being executed in an agent. Okay, so this is the script that we're going to execute. You'll see that we have a couple of import lines up at the top, typical kind of a Java thing. The first one, com.softworks.server.scripting.star, basically says import all of the classes that are provided by the server for scripting. They all fall in that package com.softworks.server.scripting. The next one is to import Java util array list, because we're going to utilize an array list in this script. So what this script does is it goes to the report macros and it gets the job batch. So that returns to us an array list of the RS server job and our jobs, and then we're simply going to write out the list of the size of this batch. So how many items are in the batch that were handed to us. Kind of a little bit of a trivial example, but it's a good starting point. So also notice that we're using the G output writer, and we're writing to that. Now when we're in a report, that would be written into the report that's being generated, but we're in a script agent, so where does that go? Well, let's have a look. So if we go over to the server, I've got a workflow here set up. We're going to draw work from another queue, just like we were before with the report agent, and we've got a RUG script agent, so let's go jump into him. There is our script that we're going to run, so let's start this guy, and we'll again load our order over into another queue, and we'll see, okay, it got processed. Executing the script, number of jobs in the batch was 71. Well, that's the output of our G output writer. So the G output writer, when it is being written to in the context of a script agent, will write that out into the log for that agent. Okay, so something else I'd like to point out here is that if we notice that with the scripts in a scripting agent, we don't have them surrounded with a begin script and an end script macro in which we would have told it what language we were using. Instead, there's actually a pop-up menu that shows you a list of all of the engines and languages that are installed. So we have Bean Shell and we have ECMAScript, which is another name for JavaScript. So those are the two engines we currently have installed, and we could have selected either one. We're using Bean Shell, so we've got Bean Shell selected. So that's how you can select the particular language that you're writing your script in a scripting agent. Now let's take a look at a little more useful example. Let's say we have a situation where you have a product that's out there and you've actually changed the billing code on it. So the ID needs to change, but you've got orders that are kind of in progress coming in, and they don't have the updated information from the catalog, and you want to be able to capture those and automatically kind of convert those. Well, a script agent would allow you to be able to do that. So In this script, we'll get the batch just like we did before, but this time we're going to iterate through all of the items in the batch. And then for each one of the jobs in the batch, we're going to get the template, which is essentially the root XML of that particular job. We're going to check the ID attribute, and if it is the old ID attribute that we're after, then we're going to change it to this new ID. So that's an example of how you might do something a little bit more useful with your script. So let's talk about the third way that a script might get executed in the system, and that's with a custom event listener. And custom event listeners listen for events to be broadcast in the system. If it hears the event that it's listening for, it will be triggered and the script will be executed. Now, there's some additional information in the greport macros table for custom event listeners, and that is the event name, the name of the event that triggered us, and event data. So there is data that will be broadcast along with particular events, and these are all documented in the scripting guide. So let's now look at a concrete example. Let's say we want to send a customer an email if we are trying to charge their credit card at the lab and the charge fails. So in that case, there is an on ePay error event that is broadcast, and we can write a script to go send an email to the customer in that case. So here in this script, we've got the beginning where we go and get the event name and the event data out of the report macros. Then we get the order and the error message that are part of the event data that is broadcast with an on ePay error. And then we get the customer order ID, so we can include that in the email. And we dig down into the order itself to get the customer's email address. Then we write into the log just to note that, hey, there was an error processing this particular order and I'm sending them an email. And then finally, we actually send the customer an email. So we're identifying the email title, which is credit card payment failure, the subject line, who it's from, Guido's Photography Lab, the actual sending email address, which in this case is me, and then the customer's email address. And then we finally give them a friendly note saying your card failed to process for order blah. Don't make me send the boys down there to explain it to you. And then we actually give them the error message. So let's jump over to the server, and here is an RUG custom listener agent that I've added into the system. We are listening for events on ePay error. It is possible to have an event listener listen on more than one event, in which case you can simply just comma separate the events that you're listening on. And we identify that we're writing our script in Bean Shell. This is just similar to the interface for the script agent. And then we've pasted our script in here. So let's go ahead and start this. And when, in order for an event listener to be active and listening, it needs to be running. So now we're going to go and start the server. I have an order already sitting in the queue that I know is going to fail on its ePay processing. And we'll start the server, and that order errors, as we can see here. The order 1526 errored while processing the credit card. Look in the ROES server for more detail was the actual error message. So now if we look, we can see that I actually do get sent that error message here, and that's an example of how you could send an email to a customer on an ePay failure using a custom listener script. So that about wraps up the intro to scripting. So I hope you found it helpful. I'd encourage you to look at the scripting guide. We'll go into more detail on particular topics I've talked about here, and more advanced topics as well. And thank you very much.